Okay, cool. So let's get started. Thank you for coming. I know not a lot of people are here. So those of you that are here, um, please try to follow along with. So we're going to be working in Google Colab and like working with an actual data set. So please try to follow along as I do because that's like the best way to sort of learn and retain the information that I will be talking about. But basically, today we'll be learning about geospatial data in Python. And so geospatial or spatial data or geographic data all refer to the same thing. And so, all of that data is so any data that is directly or indirectly referencing a specific geographical location or area. So that's what we refer to as geospatial data. And the spatial data that's available to us these days is online, is like openly available and free to use, a lot of it, and is of great use in socioeconomic, environmental, climate research, basically a lot of different fields, and might be applicable to your field of work also. So at the very least, I think it is like important that everyone sort of understand the format in which spatial data is stored digitally, and like how you can work with the data is like also important, but maybe not something that's highly relevant to your work. But whatever the case is, it's fun to at least like know how to do things with it. So before jumping into the content, I'll just sort of walk through the learning objectives. So in this 1.5 hour, you will learn about different kinds of spatial data and how it is formatted in order to better understand openly available spatial data on the internet. We will be implementing, opening, manipulating, and exporting spatial data in Python. And we will use a library called GeoPandas, which is basically like pandas, but made for geographic data. I think it's built on top of pandas. We will also make an interactive map using spatial data using this library called Folium. And Folium basically is an open source library that has really good ways to make beautiful looking interactive maps using Python basically. And all of this we will do in Google Colab. So we're using Google Colab because um, it's it's a really useful tool. It's like on the internet, so you don't need anything extra downloaded to use it, and all of us will have the same interface and same kind of um, working environment. So we will be using it. And Google Colab is basically like Jupyter notebooks. If you have used them in the past, Google Colab is the same thing. It's just made by Google. And I'll talk a little bit more about Google Colab when we get to it. So in in the world of spatial analysis, there are two major varieties of data. There is vector data and there is raster data. And both of them have different sort of use cases and different ways that they store data. But mostly in this workshop, I will be talking about we will be talking about and using vector data. So I will be focusing on vector data. Um, Also, if at any point you have any questions, just like raise your hand or drop them in the chat, or you can also just unmute yourself and talk. So yeah, so vector data is a representation of geographic data of the world, and data is represented in vector data format using points, lines, and polygons. So points are just XY coordinates. So in a 2D space, each point will have an X and a Y coordinate, and that will refer to its location in that space. Um, and then, so these points are basically used for features that are too small to be represented by anything bigger than a point. So, for example, um, if you have sort of a map of a village and you want to mark the location of, say, all the wells or all the ATMs, then you can refer to them using points, since those are just like very small features on your data, in your data. Then there are lines, and vector lines basically connect the different points or different vertices with paths. So basically, you're connecting the dots in a set order, and it becomes a vector line with each dot representing a vertex. And these lines usually represent features that are linear in nature. So, for example, maps that show rivers, roads, pipelines, so they can be represented using these lines. Um, then there are polygons. So polygons are basically, you can think of it as a closed path. So you join a set of vertices in a particular order and you close it, and this like shape that you have made with all the area inside it is a polygon. And we can use polygons to show boundaries and represent areas on a map that have, a large area. For example, you can represent a building using polygons. So you can create the shape of the building on a map using different vertices, connect all of them, and make like polygons for the buildings. And so in vector data, a polygon is stored as a list of these coordinates that define the vertices. So all of these different points, vector data stores the location of these points, and a polygon is made by connecting all of these points into a closed shape. Okay, so the so vector data is one way to think about geographic data, even outside like digital data, like before computers, like using vector data to make maps was very common, right? So how do we translate that into digital data? So that this is where something called shapefiles come in. So most of you probably have heard of GIS or ArcGIS or shapefiles. And so both of these things, ArcGIS and shapefiles, they were developed by this company called Esri. And Esri, it was founded as the Environmental Systems Research Institute in 1969. And it was founded as a land use consulting firm. So they built these like softwares for their own consulting use. And obviously, now they're like openly available. And the shapefile format, which was introduced in like 1990s, became like quite popular, even though it originated from this like one company. Now it's like openly openly shared, and a lot of different softwares use shapefiles, not only ArcGIS. So how do shapefiles actually store this vector data? They Shapefiles also work only on points, lines, and polygons. And so that's what we discussed with vector data. The shapefiles are just you can think of them as the digital version of this vector data. And so a shapefile will have all of these points, lines, polygons, and these shapes together with extra like data attributes that are linked to each shape. And that creates the geographic data representation. So for example, in a shapefile, you can have, for example, we were talking about villages. So let's say like you have points for all the ATMs in a village, you have lines for all the roads, and you have polygons for all the buildings, the lakes, and other structures in the village. And all of that, um, all of those different lines, roads can have like a name associated with it. ATMs can have a bank associated with it. So each point, line, or polygon can have extra attributes associated with it in a shapefile. So that's how you sort of add data along with these shapes, and that builds the base of the shapefile. So the name shapefile is like quite common, but it is kind of a misnomer because the format consists of a collection of files. So always you will find shape files in a directory, and the directory will have a bunch of different files. And there are three mandatory files that all shapefiles must have. And so that's .shp, .shx, and .dbf. These are three mandatory files you will always have in any shapefile you find. And you, if you don't have any of these three, then it is your shapefile is incomplete for distribution. There are also a lot of other optional files that can be included with your shapefile. Usually .prj and .cpg are file extensions that are included. So I won't really be talking about like the specifics of each of these different files because it's a little out of the scope of this workshop. But just remember that whenever you find shapefile, you will have multiple files, and all of those files are important for the shapefile that you are working with. The actual shapefile is stored in .shp. That's just like the important thing that you should remember. The shapes and all, the geometry of all the lines and the polygons, that's stored in .shp. Yeah, so for what I was talking about, so basically this is what a shapefile might look like. You have points representing these wells, you have lines representing a river, and then you have a polygon representing a lake. So you have three different kinds of shapes, and all of those combined make up this representation of geographic data. Cool. So any questions on shapefiles in this data format so far? Okay, cool. So next, I posted a link on Piazza with um, with a basically a link to this website called DataMate, and I'll share it in the chat. But basically, um, DataMate is an open source. It's maintained by a community of like enthusiasts, and it has a collection of a lot of different shape files for India. And there are a lot of different websites that that like maintain a list of different shape files for open use by people. And most you can find a lot of shape files just by like a quick Google search. But for now, we will download the shapefile repository from DataMeet. So download this. I've sent the link into the chat, and give me a thumbs up once you have it. So this is what it should look like. I think it should be called maps master or something. And then there should be a directory with all of these different folders inside of it. And these are folders with different shapefiles in them. The one that we're working with today is parliamentary constituencies. So we care about all of these files. So all of these files together make up the shapefile for India's parliamentary constituencies. So we'll be working with that. So make sure you have that. Cool. Is anybody still downloading it? Or can I move forward? Okay, I'm gonna move forward. If you haven't downloaded it and you want me to like wait a few minutes, one or two more minutes, just let me know.
Would you just wait for 2 or 3 minutes?
Yeah, okay. Just give me a thumbs up once you're, or put something in the chat once you're done. At the same time, open up collab.research.google.com and I'll put this link in the chat. Open up this website. Got it? Okay. So now we're going to be working on this platform called Google Collab. And I briefly talked about this before, but Google Collab is basically Google's version of Python notebooks. And Python notebooks are, let me actually just show you. So we'll create a new notebook for this workshop. So you should also create a new notebook on your own account and just follow along with with me as I work through the exercise that we will be doing. But so this is the view that you get when you open a new file on Google Colab. And so this is a Python notebook, and a Python notebook basically allows you to combine text. So I can like type here, I can like write about my code. I can describe what is happening in the code. I can write about the project, whatever I want to do. I can insert images. And then there are cells of code. And these cells of code you can create multiple cells. So you can have as many cells as you want, and you can run these cells independently. So I can run this cell separately, and this has some code, and I can run this cell separately, and this has some more code, but all of these cells are linked. So this Python notebook is running on something that we call a virtual machine, and that virtual machine has its own runtime. And so basically think of it as a computer that's running on Google's server, and they are giving you sort of this document that you can write code in, and all of that code will run on their server machine. Right. So you need to click this button here that says connect, and that will connect you to a runtime on Google's servers. So any question about Collab so far? We'll be working with Collab. So as you work through it, um, you learn how to use it. It's pretty useful. Okay, so one good thing about Google Colab is that it is connected to Google Drive. So if I go to my Drive, what I want to do is upload the parliamentary constituencies folder that I just showed you, that we just downloaded. Upload that folder into your Google Drive. So see, I already have this in here, but so you should upload your folder here also. because what we're doing is we're basically connecting our Google Drive to this coding Python to this Python notebook. And so all of our files can be stored on Google Drive, and all of this code will also be stored online. So it's all automatically backed up. So you can work like anywhere you have internet. You can just log into your Google account and you'll have all of your files and all of your code. So give me a thumbs up once you have the folder uploaded to your Google Drive. Jagdish, I think you disconnected. What we're doing is we're uploading the parliamentary constituencies folder that we just downloaded. This was inside the master folder, and we're uploading this to our Google Drive. So once you've done that, just give me a thumbs up. Is it uploading? Does anybody? Gopalakrishnan, Jagdish, Ramcharan, what's the status? Done? Cool. So I'll wait a minute or one or two more minutes. But at the same time, what we want to do is come back to our Google Colab, and on the left-hand side, you'll see all of these different buttons. So let's just talk about them briefly. So the first one is a table of contents. So this describes the different sections inside your Python notebook. So for example, you can add a new section and then it'll show up here. You can add another section, it'll show up there. Then there is a find and replace. So pretty straightforward. You find something in your document and you replace with whatever you want, or if you just want to find. There is this code snippets, which I have never used, and I don't think you will probably ever use this unless you're doing something very specific to this. But basically, it's like snippets of JavaScript code. There's no, I'm not going to talk a lot more about that. There's variables, so it shows the different variables that are available in your runtime. So if I were to say a equals 1 and run that, then my a variable shows up here and I can see that what type it is, and if it had a shape, I would see its shape. Then this last button here is the files. This is this is your working directory, and so this is where we want to find our folder that we just uploaded to Google Drive. So by default, Collab isn't automatically connected to your Google Drive. So what you need to do is, you see this button here that has the Google Drive ka logo on it. So, if you hover over it, it should say Mount Drive. So click that button, and then it'll ask you if you want to connect to Google Drive, and just click Connect to Google Drive. It might ask you to log in. If it does, then log in. But basically, it should mount your Google Drive um, onto your Collab working directory. So you should have this new folder pop up called Drive. And if you look inside it, Then it has all of our folders and files from my Google Drive. It also has some shared drives if I wanted to access them. But what we care about is our parliamentary constituencies ka folder inside of my Google Drive. And this is located inside my drive in the drive folder. So find your parliamentary constituencies folder, right click it, and then just copy the path. Once you've copied the path, just create a code cell here and create a variable for the file path and put your file path in here. So now you have the path to your parliamentary constituencies ka shape file folder and press this run button and you should have this green tick here. Any questions so far? Give me a thumbs up once you have this green tick. And if you're running into any problems or if you have any questions about what's going on in Google Colab or Google Drive or how, like anything, just let me know. Yeah, I'll wait for your thumbs up. So if you're done, give me a thumbs up, or if you're running into any problems, just unmute and we can talk. But I'll wait for your thumbs up before moving forward. It's loading. Okay. Oh, and also in this file path, we want to put the file path of our .shp file. So actually, instead of copying the path of the directory, copy the path to the India underscore PC underscore 2019. You might not have some of these files. Some of these files I created myself. So don't worry if you don't have these. But the one we care about is India underscore PC underscore 2019.shp. So copy the path to that and put that into the file path variable. And then run it. Ramcharan and Jagdish, are you guys following along?
Yeah, yeah. Just I joined late. We have to download that map masters, no? I download that map. It's a zip. Just
So I sent a link in the chat earlier. Let me send it again. But go to this link
yeah,
and there should be a download everything button. Press
yeah.
this
I
and then
done.
you
Yeah, I download that. It stays a master's zip. We have to extract that one.
Extract the master, and inside there you should have the parliamentary constituencies folder. And Jagdish, what about you? Are you following along? Okay. Gopalakrishnan, did you manage to upload it properly? One more minute. Okay. Okay. I'm going to move forward. But Ramcharan and Gopalakrishnan, um, put it just put something in the chat about um, where you are in the process. Downloading. Okay, I'll wait 2 more minutes. Okay. I'll continue, but please try to follow along because we'll be working through some code now, and it'll be good if you can run the code at the same time I'm running it. Or at least be paying attention to the code that I'm writing, because it'll be hard to digest and retain this information if you lose track here. Okay. Okay. So in Google Colab, just like in um, Python, you need to first install the libraries that you're using and then import them. So in a different cell, first you will have to install the GeoPandas library. And usually, if you remember from previous lectures, or from your own experience, how you install libraries in Python is either using something called pip or something called anaconda. In this, we will be using pip. In Google Colab, anytime you want to run something in the terminal or in the command prompt of the server machine that you are connected to, you first put an exclamation mark before the line, and then you write the line. So here we want to be installing GeoPandas. So the command to do that is pip install geopandas. That's what you would usually type into your terminal or into your command prompt. But since we're doing this in Collab, we want to include an exclamation mark before the line because that'll run this line in the terminal of the computer that this Collab notebook is running on. So once you've done that, we'll run it, and as you can see, it'll download GeoPandas and install it. And here it says successfully installed. So now um, we want to import GeoPandas as GPD. Similar to how you would import pandas or other libraries. Let's say like you would import pandas as PD, right? So we are importing GeoPandas as GPD. And we will also be importing matplotlib. And matplotlib is, if you haven't worked with it, matplotlib is a charting and plotting library that is very widely used in Python. And this is how you usually import it. Okay. Um, and then we'll run this. So we've imported these libraries into our system. So see how like since I've run these three cells one after the other, all of them are still all of the variables that I have introduced, all of the libraries that I have imported, all of them still exist. So here I could print out my file path and it'll still know what the file path is, even though I ran it like before this and before this cell, because all of these cells are connected and they will keep running until this runtime is running. Okay. So now that we are connected to Google Drive and we have imported all of our libraries that we are using, now we can actually start working with the data. So once we have our shapefiles in our directory and we have a variable that is the file path, we want to read that file into a variable in our Python runtime. So let's just call our variable data, and in GeoPandas, as there is in Pandas, there is a function called read file, and the read file function takes in the path of the file that you are reading. And for this, we are giving it the variable that we stored up here that points to the shapefile that we are importing. So if we run this function and save it into, um, it should, no. So let's just run these again. For some reason, it might have disconnected. Uh, oh, re, I should have checked that, but yeah, call it GPD, not GTP. But now if you run that, it'll read in the shapefile into this data variable, and we'll see what that looks like. So once you've run that, create another cell and print out data.head. And the data, the head function basically just prints out the first 5 rows, just so you can have a look at it. So see, this is what the shapefile data looks like, the first 5 rows of it. We have the first column here is just the indices, so it starts from 0. This column here is the state name. So we have Himachal Pradesh, Punjab. We have a lot more, all of the states probably, but this is just the first 5 rows. And then this column, the third column here is called geometry, and this column is the one that's really important to us. And So you see it says here polygon. So it's storing the constituency, the constituency's shape as a polygon. And inside the polygon shape here, you see it has like a list of these numbers. So these are lat longs. And these lat longs, the list of these lat longs define the vertices of this polygon. And the vertices of these polygon make up the shape of the polygon. So each constituency has a shape that is defined by this polygon in the geometry column. So just keep that in mind, okay? So cool. Any questions so far? Okay, so one interesting thing is if you look at the type of the data. Oh, I think my thing disconnected again. So let me run in this again. If this keeps happening to you, you might need to keep running all the cells again. Ideally, I don't think it should happen. Like you shouldn't be your runtime shouldn't be crashing like mine is. But if it is for some reason, then just run things again. Cool. And then if we see the type of the data, we see that it is a geodata frame. So in pandas, if you remember from the previous lessons, or if you have worked with it, you know that data sets are stored in something called a data frame. And a data frame is basically just another word for, or is the object in a pandas, is an object from the pandas library that has all of these defined functions and methods with it that you can work with. So a geodata frame is the same thing, but with geographic data, and it comes from GeoPandas. And this geodata frame has a lot of different functions that we can use. One interesting function is data dot. So data is our variable here, and the function called plot. So this function will plot your geographic data onto uh, onto a plot which is made using matplotlib, which is why we imported the matplotlib library. So as you can see, these are all the constituencies in India, and so these lines. So there's a, let me make this figure bigger. So the plot function takes in an argument called fixed size, and that fixed size you can define to whatever size you want. And sorry, yeah. So all of these shapes are created by these polygons that I was talking about. So for example, this constituency in Punjab is defined by this polygon shape. And so are all of these other ones. And all of these combined um, create the entire data of entire geographic data set of Indian parliamentary constituencies. Cool. So now let's talk about something called the coordinate reference systems. So the world is 3D, right? Like the globe is a sphere, and moving from a 3D surface to a 2D surface is called creating a projection. So you're creating a projection of the 3D surface onto a 2D surface. And um, before computers and like big calculators, we used to do this using physical paper and physical globes and a source of light. So you can imagine, say you have a sphere, and you have shapes on the surface of that sphere, and then you have a source of light inside of it. Then you put a cylinder around the sphere and you capture the projection that is coming from from the light. So the shapes on the sphere will create a shadow onto this surface, on the inside surface of the cylinder, right? And so imagine you capture those shadows onto the onto this surface. So you draw the projection on the inside of the cylinder, and then you cut the cylinder up, and then you unfurl it into a 2D, into a into a cube, into a rectangle. And then you have the so you've captured the projection from a 3D object like this sphere onto a 2D surface of this cylinder. And then you can do that with different kinds of shapes. So you don't necessarily need to have a cylinder here, right? You can put a cone on top of the sphere, or you can put just a sheet of a circle on top of the sphere, and that'll all of these different shapes will capture the 3D surface onto the 2D surface in a different way. And so these are called different projections of a 3D surface onto a 2D surface. So there are a lot of different kinds of these projections. And one interesting one that you have probably heard of is is the Mercator projection. There is there are a lot of different there are a lot of different projections, but the Mercator projection is the most, like, the popular projection of the world you see onto maps, which preserves like the shape of the countries. So different projections preserve different qualities of the data. Some projection might preserve the shape of the countries. Some projections might preserve the area of the different countries. So which system we use depends on what quality we are from our looking to get out of our projection. Right. So these projections are what we call coordinate reference systems. And each geodata frame in GeoPandas has associated with it a coordinate reference system. So if we run this line, basically this line is accessing the CRS, which is the coordinate reference system of our data. It'll show you the information about the coordinate reference system that it is using. So you can see that our data right now is using this. So this here is the code for the coordinate reference system, and it's using the lat long system. And this is just information about the CRS. So why this is important is, say we wanted to find the area of all of our constituencies. We wouldn't be able to find the area accurately with the current CRS, and that's because the CRS we are using right now is a CRS that maintains the shape of the constituencies, and it has locations in terms of latitudes and longitudes, so in degrees. And we can't use that to accurately find the area of these constituencies because these aren't all accurately scaled in relation to each other. So this constituency here, so the Ladakh constituency isn't accurately sized compared to, let's say, like this constituency here in Gujarat. So there's a function called dot two underscore CRS, and you can give it a dictionary containing the word in it and the code of the CRS you want to use, and that will convert the reference system that you are using for your data into this new CRS. So this CRS here, if I Google this, Um, if I Google this, we see it is a Mercator projection. Um, and it says here that the unit that it uses is meter. So now this new CRS that we're using has locations stored in um, in meters. So you see these numbers have changed from before. Earlier it was lat longs. Now these are meter. The unit of these numbers is meters. And now since our unit is in meters and our projection is accurately saving the area of these constituencies, we can find the area of each of these constituencies. And the way we would do that in GeoPandas is one way to do it is to iterate through each row in our data. So in GeoPandas, similar to how you would do it in Pandas, we use the function called iter rows. And basically .iter rows um, is the way you iterate through a geodata frame or a data frame. And inside of the for loop, you will have the index and each row. And within each row, we know there's a column called geometry, right? So this column here, geometry. And if we just print that for the first line, we will see that we get um, the polygon object here, and that has a list of all of these lat longs. The reason it's still in lat longs is because we didn't save this converted data frame into our original variable. So let me run that again. And now the data variable should have a data frame that's using this updated CRS. And now if we run this, we get a polygon in meters. And for this polygon, there is a function called .area. And this basically calculates the area of your polygon. So if we run that, we see it returns this big number. And so this is the area of one of the first row, the area of the first constituency in our data set in meters squared. So this is how you would, so, and if I remove this break and do it for all of the constituencies, we get the area for all of our constituencies. So this is how you would sort of play with the coordinate reference system if you wanted to calculate the area of your constituencies. So this is just one of the many functions that are provided in GeoPandas. I obviously can't walk you through all of them. So instead, like what I'll do is walk you through the documentation. So for all libraries in Python, it's the documentation is the most important resource, and it provides basically like all of the tutorials and information about all the functions that are available to you. So if I go to the GeoPandas documentation, which you can find quickly by a Google search, you'll see it has all of these different like tutorials on different things. So there's a user guide. It tells you about all of these data structures. It tells you about how to read files. So basically what I showed you right now. So like reading files. You can also read files from URLs. You can um, you can see how to index into data, select data. You can see how to map. You make maps, make plots. You can see how to do different geographic manipulation. So you can find centroids. You can find the boundaries. You can scale things, translate things. So all of these different functions that are available to you through the GeoPandas library, you can it's highly recommended that you go through the documentation just to know what's available to you. And usually, in the future, if you are working with geographic data and you want to do a certain task, let's say you want to group all of the constituencies in a certain state, you can come to the documentation and then you can search for what you're looking for. Let's say I want to um, know how to group things. Um, so I can search that and then I can probably read through the results here and find out um, what I can use to group things. I think there's a function called group by. Uh, yeah, so a geodata frame has all of these different functions. Okay, so that's the documentation. I am not going to I'm not going to talk through a lot of the other functions, but I'm going to move to a different task for now. Okay, so the next thing that we're trying to learn is how to do geocoding. So what geocoding is basically given a list of, let's say, addresses. A geocoder will find the lat long of that address or the location of that address in whichever coordinate reference system you're using, and it'll give you the location of that address. And this is important for a lot of different, so this is one of the very common tasks that you would maybe have to do with geographic data. Let's say you have a lot of different addresses from some data that you have gathered through a survey, and now you want to plot those addresses onto a map. I mean, the first thing that we could do that could come to your mind is to look up things on Google Maps, right? So if you look up the address on Google Maps, it'll show you exactly where it is on the map. But we can't do this manually for, say, like thousands or even lakhs of addresses. So we need something faster and something that works for large data sets. And this is where geocoding comes in. So you give it, so there are a lot of geocoding services. So Google's geocoding API is one of them. And there is OpenStreetMaps, Nominatim. This is open source. So a lot of these services that basically do the geocoding for you. So you give them the address and they will return the lat long of that address to you. So we will use, you will using this Nominatim, OpenStreetMap Nominatim service to geocode addresses. Um, so we could get a list of addresses from somewhere. I have a list of addresses that I can just copy paste here. But if we had a little bit more time and more people, we could have created our own list of addresses. Um, so if you just to show you what that process would look like, let's say you have a Google Sheet like this. So I have currently my hometown. I'm from Lucknow, so my hometown here, and I can put in another address. That's my current location. And I can populate this spreadsheet with a lot of different addresses and name all of them. And then I can download that as a CSV. I could then load this CSV into my Google Colab using pandas. and then use those addresses to geocode and to get the geolocation of of those addresses. But for now, I'm just going to copy paste some addresses into my Collab, just to show you all how it would work. So I have this list of addresses from Finland, and I have currently stored it into a variable called addresses, and it is a string. So this is one long string um, that I will read using pandas. So in pandas, let's name our variable df, and so we would do pd dot data frame. So we are making a data frame, and then let me write the code first, and then I'll explain. Cool. So what we're doing here is we are first splitting this variable addresses on a new line character. So \n refers to a new line, and we're splitting addresses based on that. So this will return a list of all of these addresses separately. So if I were to show you just what that looks like, let me do addresses dot split, and so you see that returns a list of these addresses. Cool. And for each of those address, so for X in this list of addresses, I want to split it on the colon here. So on this. So once I do that, it'll give me two columns. The first column is the ID, and the second column is the address. And we are putting all of that into a pandas data frame. So if I print out the data frame, you see I get two columns. The first column is the ID, and the second column are the addresses. Cool. So now we have these addresses in a pandas data frame. You could, similarly, if you were using your own spreadsheet, your own CSV file, you could load your load your CSV file using read underscore CSV, and then you would get the spreadsheet as a pandas data frame, and you would use that. So for geocoding in GeoPandas, we need to use a library called GeoPy. I'm going to install that. And GeoPy is basically a Python library that provides the geocoding services through these different service providers. So GeoPandas is using the GeoPy library, which itself is using these service providers to allow this geocoding to work through GeoPandas. And for geocoding, we need to import the function geocode, which is in geopandas.tools. So again, this is something that at first you might be like, how do I know this? Like, how would I know this when I haven't actually ever used this in the past? If you look up geocoding in GeoPandas, there's this whole document on the website in the documentation that talks you through exactly how you will use it. Right. So basically, you could, if once you know how to load your shape files, and once you know what shape files are and what you can do with them, you can do any of these tasks easily. You just have to Google them. So once we have imported our geocode function, we need to call it. And the geocode function takes in a list of addresses. So we will give it the address or this first column here. So we want to give it df1. So because that is the first column here with all of these addresses. We want to give it the list of the addresses. We want to give it a provider, and the provider that we're using is called nominatim. Again, this is like explained on the in the documentation, like right here. This is the exact line that we're using. So you have a provider, and then you need to give it a user agent. So user underscore agent, and then this can be named anything. So I'm just gonna put my name in here. And then I'm going to save the output of this function into a variable. Let's just call it O for now. Then I'll run this. Okay, it seems like my runtime crashed again. So I will have to run things again. Okay. We don't really need those cells. Then we run this. Cool. So it seems to be running. It seems like my Google Colab crashed again. It's unfortunate. Let me try and run it again. I don't know why it keeps crashing. Yeah, I hope you guys are following along. If not, I will share this entire Google Colab notebook on Piazza along with the slides, and then just please like look through it and work. You can run the code yourself and play around with it. Let's just see if this works now. Cool. So that finished running. Let's see what the output is like. Cool. So this is what the geocoding function returned. It returned two columns. The first is is geometry, which are just points, and these points are lat longs of the addresses that we gave the geocoding function. So just like that, we have gotten the lat longs, the location of 36 of these addresses very easily. And then we can use these lat longs to for whatever like research purpose we have, or to visualize our data. So we can put these lat longs onto a map, right? So what I'm going to do is we are running out of time, but I'm quickly going to show you how you might use this library called Folium, which I'm going to quickly install. But let me just show you its documentation. So Folium is a library that allows for pretty beautiful looking HTML based visualizations. So builds it builds maps for you that look beautiful. And it does that by using like OpenStreetMaps, which is an open source like community collaboration mapping um, mapping organization. There's Mapbox. It uses a bunch of these different things, but you can look through the documentation. But how it's used basically is first you install it as we install GeoPandas. Then we're going to import it. Um, and then in Folium, you first need to instantiate your map. So I'm going to create a variable called my map, and you need to create an object of the map class from Folium. So that will create the map. And if we just do that here, you see, so this is a detailed, pretty nice looking, in my opinion, map of the world. And this is dynamically generated using Folium. So Folium is a library that can create maps like this for you in Python. So what we're going to do is where we will add all of these lat longs that we just found for all of the addresses in Finland, and we'll add them onto this map. And so how we would do that is first, so think about all the different points here, and how we could add each of them to the map separately. So it seems to me like a good method to do this would be to make a for loop that goes through each of these addresses and plots each point onto the map. That seems like a good method, right? So just like we do in pandas and we've done in GeoPandas, we will use the function iteros or iteros to iterate through our list of locations. And for each location, I will create a variable called marker. And Folium basically has a bunch of these different classes that you can use to create objects for your map. And marker is one of them. There are a lot of other ones. Let me just show you the documentation of the marker. But so yeah, so see, you can add like layers to your map. You can add a marker, you can add a pop-up, tooltip. So all of these different things that you can add to your map. And the documentation has code for doing it also. So if any of this sounds like something you want to do with Python, then please look through the documentation. But the Folium marker class takes in the location of the marker, and the location basically we get from our geometry column, right? So all of our lat longs here are in this geometry column. And so we will access that column and get the y coordinate and the x coordinate. So for these points, you can just access the y and the x like that. And the marker class wants the location as a list of the lat longs. The reason why I put .y first before .x is because the location, it wants the location to have the northing and then the easting. So the y sort of refers to the northing, which we refer to as the latitude, and the x refers to the easting, which refers to the longitude. So we give it the location like that. So that will create a marker for us. And now we just simply need to, there's a function for the marker called add_to, and we will add this to my map. and this will add all of our markers to the map. The reason it is giving an error right now is because there are some points that we couldn't find the address for. For example, this one, there is no address here and this is empty. And so Python gets confused with those empty locations. So we need to just do a quick check. So if we do if location, and we will check if the second column is none. So if it is not none, then we want to create a marker and add it there. So these are all the different addresses we just geolocated in Finland. Cool. And finally, we can save this map. So my map dot save is the function, and you give it the name of an HTML file. So I'm just going to call it index.html, and that will save this index.html file into your Google Colab and you can see it on this directory view in the left, and then you can right click and download it. And if I open it with any of my web browsers, let me show you. If I open it with a web browser, I get this good looking full screen HTML map with all of my addresses. Cool. So that's most of what I wanted to cover, and we are also running out of time. So shapefiles. So now we know what shapefiles are, how to open them in Python, how to look through documentation to work with our shapefiles, and we know how to create maps using this library called Folium, or at least we know what are the possibilities, that what the possibilities are with these different libraries and data. And then in the future, now if you want to work with geographic data, you can find shapefiles that you are interested in. You can open them in Python. You can work with them using GeoPandas. So if you want to do different tasks on it, you can find out how to do them using GeoPandas. And you can create visualizations using this library called Folium. So this isn't the extent of geospatial analysis by any way. Like there's a lot more to geospatial analysis. There are different file formats that exist. GeoJSON is one of them. But to start off with, I think this is a good base. And I will, after this class, make a Piazza post with the code from the Collab file and all the slides. And I will also link to some resources that you can use to learn further about shapefiles and spatial analysis. But yeah, that's all that we're covering in this workshop today. Any of you have any questions? If not, then we're done. Thank you for coming, and hopefully this was useful to you. And if you're watching this like later on YouTube, we can also link the code and the slides in the YouTube. So if you want to work through the code, you can do that at your own time.